All three angles added up, they add up to 180 degrees. A fancy way of saying that is our triangle angle sum theorem that we're going to start with. The triangle angle sum theorem, it's a fancy way of saying in a triangle, all three, and this is important, interior, all three interior angles add to 180 degrees. Just a fancy name to it. All three angles in any triangle add to 180. All right. So let's use it now. Most of these problems I'm going to work with you on do not have a diagram because I want you to get in the habit of drawing your own diagram based on the given information. So example 1, draw your own triangle. There is no name for it, so there doesn't need to be any vertices. If you want to put them on yourself, that's fine, but no name here. And I'm giving you all three angles, so please place those three angles in your triangle when you are ready. 2x, x plus 10, and 3x minus 10 when you are ready. And I'm asking you to find x in part A. Find the value of x. We do not know any of these angles are congruent, but I do know what about all three, so I can set up an equation. What do I know, Isabel, about all three? So let's make them, add them up, and set them equal to 180. The 2x, the x plus 10, along with the 3x minus 10. Yes, they all add up to be 180 degrees. Go ahead, solve for x. That way. When you find x, let myself and your classmates know when you're ready, Sully. 30, good. Now in part B, please substitute in 30 and find the actual angles of all three. Find the actual measures of all three angles, excuse me. And make sure before I call on you, you're confident because all three angles you list me should add up to 180, right? Those three angles should add up to 180. Nothing less, nothing more. And when you're ready with those three angles, enlighten us, please. Wow, this is dramatic. Oh, just to hear from Michael. Here, what do you got, Michael, when you got him?
2x equals 60.
Yep, 60 degrees. What else you got? What other angles?
X plus 10 equals 40.
40, and how about your final angle?
3x minus 10 equals 80.
Perfect. So I got 60, 40, 80. Yes, they do add to 180, so we're good. Now I want to tie in yesterday's class. Classify this triangle. Remember, we're doing it by its angle. So we only have 1, 2, 3, 4 options. Equiangular, acute, obtuse, right. Those are my only options. Not isosceles, scalene, or equilateral, because that would be if I knew its side lengths. When I know its angle measures, I only know 4. I have 4 options. So if it's 60, 40, and 80, the best name for this triangle is going to be what type based on those angles, Natalie? That is acute. Why? All three are less than 90. Perfect. All three less than 90. Look good. All right, that was not bad, right? That was not bad. Let's go to a little bit more tougher one because I'm going to reintroduce a couple vocabulary terms. All right, draw yourself triangle ABC now. Now we're naming it. So make sure the vertices are A, B, and C. Does it matter where they go? Absolutely not. A, B, and C can go on any of the 3 vertices. All right, let's keep reading. Angle A, 40 degrees. Plug that in wherever you have angle A, 40 degrees. Wherever you have angle C, let's make that 30 degrees. And here's where it gets a little crazy with our vocabulary. We're going to draw a line segment C to D, and look what it does. Look at that word up there. It's going to bisect angle C when we draw it in. And where's point D located? Somewhere on AB. All right, so somewhere on AB is point D. And we're going to draw in segment CD. But as we do it, angle C is getting bisected. So here's what I want from you. What else are you putting on your diagram now? And where? Okay, because there's something else I could put on my diagram other than line segment CD. It was bisecting angle C. Anything else here, Fiona, I can throw on?
The like tick marks on A, D, and DD.
Is D a midpoint? What's it bisecting? The angle or the side?
The angle.
Okay, not the side.
So congruent marks on C.
Okay, I don't want to put hash marks over here because that's not getting bisected, just the angle. Everyone good on that? Put me arc marks there. All right, let's do this. 180 degrees in every triangle, 180 degrees. So if I go ask for angle B, I already know two of the three angles. Here. What's 1, 2, third angle, Julia? 110. Where's Julia getting 110 from? 180 minus the 40 and the 30. My recommendation, and I'd like you to follow it, when you are doing a multi-part question like A, B, C, D, and E, and so on, once you find an answer, put it in your diagram because you may need it down the road. So once we had 110, I'm going to plug in 110. I may need it. And for me to see it is much better than me to write it over near part A. Next up, ACD. Fiona gave us the arc marks. I'm glad she didn't give us the angle measurements because that's what I'm asking for now. How about ACD? It got bisected. Angle C got bisected. This is taking forever. But it's going to be worth it. It better be worth it. It better be worth it, Max. 15 degrees. It was worth it. All right, 15. And I'll put a 15 on the other side because they're congruent. Oh, now angle ADC. And here's the big point. So now I'm going to get a little louder if I need to make a big point. Here's the point, ladies and gentlemen. Any triangle has how many degrees? 180. I don't care if it's a tiny one, a large one, or in this case, a triangle within another one. All of them have 180 degrees in them. If it's got three sides, it's got 180 degrees. I don't want you to think it has less because triangle ADC is inside big triangle ABC. No, if it's got three sides, it's 180 degrees. All right, now can we find angle ADC? Whew, out of breath now. Isabella, what's good with angle ADC? Let me turn your focus right here, Isabella. See that triangle ADC? How many angles do we know in it? 2. So we could find the third now. Okay, because they all add up to what? 180. So go ahead and find that missing angle for me. $125. Does everyone see what I'm saying now? Even if this is a triangle within a bigger one, they still all add to 180. So good, 125. And then I love part D because you don't have to do anything with triangles to find part D, or you can use triangles. All right, there's 2 different methods to get to angle BDC. One using triangle, interior angles of a triangle. One using a geometry fact we talked about all the way back in Unit 1. Either way, find it for me. BDC, when you're ready. Gianna?
55.
Okay, let me ask you, how did you find the 55?
I just did 125 plus 15.
Good.
Or 180 minus 125.
So here's what Gianna used. Hey, I'll now use that triangle where I know 2 angles and I'll find the third. The other method, see that 125 we just found? Sully, what is it with the 55 next to it? Linear pairs or supplementary. Guys, anything, please keep realizing this year, anything goes. Just because it's triangle day or angles in a triangle day doesn't mean you got to use it. Anything goes. Whatever is going to get the job done here. All right, if you saw linear pairs, go for it. Don't think, oh, I got to use triangles. No, you don't. Use whatever you want. And example 3, here we go. All right, triangle ABC, let's get it done. Angle C is 72. Seems like now it's coming up every unit, isn't it? Angles in a ratio. We cannot use the 2 and the 7 by themselves. That doesn't make sense. 2, 7, 72, not even close to 180. If we want to use them in an equation, we take the 2 and the 7 and attach x's with them. Yes. So on angle A, we're going to put 2x. Angle B, we're going to put 7x. All right. We can't use the numbers in the ratio unless they have x's with them. So now, what do I know about all three of those angles there, Sakura? All right, let's do it. And I'm letting you guys go all the way with this one now. Find me the angle measurements. And all three should add to 180, remember. In case I call on you, you can be confident. When you're ready. Shroom, hello, Gianna. Back to you. Angle A and B when you're ready.
24 degrees.
Yep.
84.
Good job. Great job. And if I add that with 72, yeah, I get 180. Anything about interior angles? Because now we need to go take a peek. We're going to go outside now and talk about how to find the measure of exterior angles of a triangle, okay? Exterior. Some new vocab before I do that. Don't worry about my diagrams here. Some new vocab. Up on the triangle there, I have 3 different exterior angles, 3 different interior angles there. What I'm going to have somebody start out the chart with is name one of the 3 exterior angles. Name one of the 3 angles that are on the outside of this triangle here. And then we're going to start our chart off with that one right there. Maddie, start us off. Anyone?
Angle 1.
Okay, way to be creative. Good. Angle 1. Can somebody now give me the interior angle that's adjacent to angle 1? Okay, you have angle 1. Give me the interior angle that's adjacent to it. That's where the lowercase letters come in. Here we go. Sakura, what's the interior adjacent angle? Lowercase a. Perfect. Here comes the new vocab. If it is interior and it's not adjacent, if it's interior and not adjacent to our exterior, we are going to refer to these angles as remote interior. I like using that word better than non-adjacent interior angles. That's a mouthful, right? That's a mouthful. So again, a remote interior are the two interior angles that are not next to the exterior we are talking about. So in this case, Maddie picked angle 1 for the exterior. What would be the remote interiors in this case? The 2 that are not adjacent to it. Maddie, back to you.
Angle B and angle C.
You got it. Angle B and angle C would be considered remote interiors if we're talking about angle 1. Okay. Now, they'll change once we pick a new exterior. Speaking of that, Ryan, pick a new exterior. Oh, you guys, I'll tell you. Creative. Angle 2, good. How about the interior angle for that one, Max?
Angle B.
Angle B, thanks. So if we're looking at angle 2, what are my remote interiors? Bless you, bless you. What are my remote interiors in that case? Ryan, back to you. Angle A and angle C. Perfect. All good? And then I won't even ask anybody here, but the third exterior angle is angle 3. The angle adjacent to it inside is angle C, making my remote interiors A and B. All right, you're going to get back into your groups in a second. Before you do that, can you copy down my 2 beautiful looking triangles here with their exterior angle off to the side? Yep, you guys got plenty of white space there, so can you copy down those 2 triangles for me before I put you in the groups and tell you what your jobs are? You and your groups are going to discover today's theorem. I am not going to give it to you. You are going to discover it on your own. What do we need?
Is it 50 in the second one?
That is 50, yes, 50. All right, you're going to have about 2 to 3 minutes to do this in your group. First job in your group, find the remaining interior angles of each triangle, okay? You guys have enough information to do that. You are going, not right now, when you get in your groups, you're going to go to each triangle and find the remaining interior angles. Then you are going to look at each triangle for me and see if you can come up with a relationship between the exterior I gave you and the 2 remote interiors for that exterior angle. Can you find a relationship between them? And that hopefully will be our theorem for today that you discover. All right, so again, number 1, find the 2 remaining interior angles. And then 2, look at the exterior I gave you and the remote interiors and see if you see a relationship. Go ahead, talk to each other, move your desk around if you need to. This will not be the only time you work together today. Make sure you guys agree on the interiors. And then see if you can see the relationship.
10-year pay. And then
10 for one of them, and then 7 for the other.
Like that.
Because one is
Yeah.
170. And then we can find the inside angle, which is, what is it?
120
Wait, at all? For 50.
And then for the other one, would be just,
Yeah. And the relationship is like,
Wait, what are the 2 remote interior things?
oh, they add up to it.
well, also it's like exterior minus interior equals other interior.
Can you say that again?
Oh, okay.
Like, so the exterior
Wait.
of 170 minus
Then how do you know this one wouldn't
an
be?
interior of 50
It is
equals
it.
1.
Oh, I see.
Same thing here.
You mean how you
The
know?
exterior of
Because
110
that's the adjacent.
minus
Oh,
the
I
50 we were given equals the other interior.
Should we write it in the
60.
Oh, you think you know my theorem already?
Yeah.
Is the 2.
You think you know the exact wordings and everything?
Not the
Oh,
exact
no, not the exact
Okay, all right.
I know what it is.
2
Should we write down the theorem, or should we just, like,
You think you know my theorem?
added to
maybe not word for word?
The exact, okay, well, we'll talk.
That's fine.
Wait, what is it?
Remote interior angles add up to
Or like, yeah.
correlating, non-correlating remote interior angles add up to.
All right, here we go. Sounds like everyone's on the track of our new theorem here. I filled in all the different angle measurements there for us. What'd you notice about the exterior of each of them and the remote interiors? What is it, Sully?
They add up to the exterior.
The 2 remotes add up to the exterior, right? So 170, 120, and 50. Hey, they add up. 110, 50, and 60. They add up to 110. Perfect. That's it. That is the theorem we're looking at. So here's the official one. In a triangle. An exterior angle equals, guys want to finish it? What's it equal to? Any exterior angle is equal to,
The remote interior.
what about them?
The sum of.
Got to add them, right? You can't just take one remote. You got to add both up. And when big boy, big girl word for the answer in an addition problem. Sum equals the sum of the remote interior angles. There it is. There's our big theorem of the day. Exterior equals the sum of the remotes. Always, always, always. Good deal? All right, let's try it out now. On example, what is this? Example what for you guys here? Example 1? Okay, on example 1, I want to use the theorem. I don't want you to find the remaining interior, then find its exterior. I want you to use the theorem we just had, which says exterior angle, X, equals the sum of the two remotes, which are what in this case? What are my two remote interiors to X? Ryan, on fire today. On example one, I have exterior angle X, and I'm asking what are the two remote interiors for it. So that angle X is equal to those two added together, which give me 130 degrees. I wanted to use the theorem there. Questions? Oh boy, wait till you're gonna hate this one, and I'm gonna love it so much. Let's do it. Here we go. Buckle up. Angle A, X squared. Woohoo! Minus 6X. Angle B, 2X minus 3. And, okay, ACD. Everyone see where that angle is? It's not interior, it's exterior. Yes, yes. ACD. 9X plus 27. I do not want you to go down this road. Nobody is finding angle ACB. You can't go 180 minus 9X plus 27. All right, we're not going down that road. Instead, we're going to use our theorem. Remind me of the theorem again. Exterior angle, which is what here? What's our exterior angle, Sophia?
2x minus 3 and x squared minus 6x.
I was just looking for the exterior. What's the exterior angle in this one?
9x plus 27.
9X plus 27. And now go ahead. What's my two remote interiors?
2x minus 3 plus x squared minus 6x.
There we go. All right, does everyone see the theorem being applied now? Right there, that's the theorem. My job's done. You know what we have to pick up with? Algebra 1 last year. All right, we just applied the theorem, so I'm done. Is everyone all right on this right side if we combine like terms and write it in the standard form order here? 9X plus 27. I'll put the x squared first. I'm going to combine the 2x and the negative 6 to get negative 4x. And then minus 3. That look good? Yeah. Oh, boy. We haven't done this too many times this year, but you're going to see it more and more. Anybody going to know what's going to end up happening here?
It's a factor.
He said it. He said the word. He said it. Yeah, you are going to have to factor. How does he know it's factoring? Well, here's how I know. Because you have an x squared and an x all in the same equation. That's automatic factoring. Not yet, though. You're not ready to factor yet. Anybody know why? You can only, Michael, factor.
One side has to be equal to the
Darn right. And I always like to make whatever squared positive, which it is. So can somebody help me move over the 9x and the 27 here? Choom, Riley, how do I move over the 9x?
Oh, subtract on x or both sides.
Yep, and now how about the 27? Because we're in honors, and I feel like we can do it at the same step.
Yeah, just subtract it.
Subtract it as well. Make sure it's combined with the correct numbers and expressions over here. So now it's equal to 0. What do you get on the right side now? Combine everything for me. Choom, Michael, back to you. X squared.
x squared minus 13x minus 30.
Yep. And this is you guys had probably multiple ways to factor last year, methods. You probably had like GCF, multiply, add to this, I don't know what other methods they're showing in the middle school these days, but this is the only method I'm going to have you do this year, which is the following. Two numbers that multiply to negative 30, but at the same time, those two numbers should add to negative 13. That is the only method you're going to be responsible with me this year anyway. Next year, you got to rehash everything. Be careful. This is a trap one. There's a trap pair in there. People think this pair works, but they don't. All right, there's a trap pair. So I need two numbers that multiply to negative 30, but at the same time are going to add to negative 13. And however you did it last year. Some people go to there's a calculator trick. You can go to your table of values on Grapher. There's like a magic X method. And I'm like, I think I don't teach algebra 1. All right, hopefully you didn't fall into the trap pair. Hopefully you did not fall into the trap pair. Anybody got those numbers for me? Julia, what's good?
X equals 15, X equals negative 2.
Okay, so 15 and 2 are your numbers.
Oh, yeah.
Okay, not 10 and 3. Those were the trap ones. Because look, 10 and 3, you can make them add to negative 13 by making them both negative, right? But the problem is, go ahead and multiply them. What do you get? I need a negative, though. So that's why 10 and 3 were traps. And it would be negative 15 and positive 2 inside. Now take it out to figure out what X equals. I don't need to see this because many of you understand that the answer is just going to be the opposite of what's in the parentheses. So I don't need to see this, but I'm showing. If you don't know where the answer comes from, here it is. I set both parentheses equal to 0. So Julia said it earlier, X equals 15, X equals negative 2. Unfortunately, I would love to circle both of them, but we are not. And here's the first time I need to talk about this year, where you guys got to be on high alert. High alert. Guys, did a diagram come with this problem? It did, didn't it? All right, a triangle came with this diagram. What am I pushing you towards? One of our answers was negative 2, wasn't it? Can you go back up to the diagram and substitute in negative 2 for angle B? And see if you tell me if there's a problem. Anybody got an issue if you substitute in negative 2 for angle B? There is something we have never seen at all. At all, Fiona, what is it? You can't have a negative angle. You cannot have a negative angle in a triangle. Right? So if that occurs, where you substitute in one of your answers and a negative angle is produced, that is not an answer. All right? That is not an answer. We need to go back and, this is fun part for me. Where's my big X? And reject that sucker. Not because it's negative 2. Why am I rejecting it? Because when I go to plug it back in, it's going to give me a negative angle. That's why I'm rejecting it. How about the 15? Is the 15 okay? Yeah, anywhere you plug in 15 for X, it will always be a positive angle, so 15 is fine. Be on alert, especially when you get 2 answers out. One of them might need to be rejected if there's a diagram. Yes, Joe, go ahead.
Do you have to say something or you just
Nope, just cross it out. Cross it out. Fiona.
What happens if they're both positive?
Still plug them back in. A positive answer, depending on what's written here, may result in a negative answer. Okay? Because look, let's say, hey, ready? Perfect example. Let's say one of our answers was positive 1. 2 times 1 minus 3. That's going to be a negative angle again. So just because it's positive doesn't mean it's okay. You've got to plug it back in and try it out. Great example. Max.
Can you scroll down?
Sure.
I think you already said this. Do I have to show that step after the?
Right here?
Yeah.
No. I was just showing in case kids didn't know where to go. Sully, let's go, guys. Great questions.
You have to show you plugging it back in.
No, I just need to see the X that you're clearly rejecting it. Okay? That's clearly being rejected. Great questions. Anything else? Go ahead, Isabel.
What if you plug it in and it's 0?
No. 0 can't happen. Okay? 0 or negative. That's not an angle. Okay, another good question there. Yes,
If it's over 180, do you also have to reject it?
yes. Everything you're talking about, by the way, does exist, not until Algebra 2 next year. You actually can have a negative angle. You can have an angle bigger than 180. I'm not going to get into it. You'll learn about it next year. But for now, that ain't happening. All right, Julia, go.
Can two of them work though? Like,
Both?
yeah.
Yeah.
Okay.
Two of them could. That's why you got to check. All right, even the negatives could work. Okay, even the negatives could work, but that's why you got to check both. Anything? Go ahead, Sully.
If they both work, do you have to put out like both?
Both
answers?
are solutions, correct. So if -2 ended up being positive angles for all three, I'd have to circle -2 as well. There could be multiple
Would
answers.
you also have to like write out like the angles that they're? Oh wait, no. It's not.
Nope, I wasn't finding the angles. They just asked me to solve for x. Anything else? Okay, you are getting back into your groups right now. Whoa! Whoa! Nobody. See, this is you guys got to look up the darn screen trend. Well, finally, Promethean person just appeared. Is this the first time this year?
Yeah.
Yeah.
Oh, this is huge. No, could be no homework going into the weekend. Could be. What I'm going to do now is take nominations from you of what the next one could be. I will write down all the nominations. Then we will vote. All right. Top vote getter. I will go. I'm all out of slides. I will go back a slide and do it again. If it's the one the class majority picked, no homework. If it's something else, we got homework. What?
If it were to be the Promethean person again, can we have no homework if we were to guess it? Like no.
You got to
homework
guess
for a
it.
week?
You have to nominate and be majority
Because
again.
it's
Yes.
like so rare. Could it be like no homework for a week?
No. No, that's if you want to not. Everybody good. And it has to be the majority. It can't be like, hey, it's going to be cube, and one person votes cube and it's cube. No, that doesn't work that way, that one person doesn't get homework. All right, it's all or nothing. All right, so I'll start the nominations with that one.
What if we tie between two?
Cube, then we revote. Kids have done that. They get a little sneaky and they strategize. So like, I'll get 3 votes on that, 3 votes on that, and then maybe Mr. Carlino will let me have all 3. No, that's not happening. So I've done this too long. Cube. All right, next one. What else could it be? Let's roll. Cameron. Star. Just here we go. Yell them out.
Book.
Book. Yep, there's book. Curtains. Flip. Come on, you've been here almost 2 months.
Pinwheel.
P-dubs. Pinwheel. Yep. There's like
Pythags.
16 or 17 of them, by the way.
Pythags.
What is it?
Whatever his name. Wait, what's his name?
Promethean person?
Yeah.
You say Pythags? Promethean person. Yep. Again. Come on, there's like 16 of them, I think. Clock. There is a clock. Yep.
Slide.
There is slide. Which direction?
Fade left.
Slide left, slide right.
There's slide left and slide right. There's just fade. No direction.
Isn't
We're
there
missing a
also
lot.
like page?
Oh, book.
Curl. No, there is page curl. Yep. That comes up here. Yep. There's one that came up today that nobody has said yet.
Star.
It's like a waterfall one. What is it? It like goes like
Genie, Maddie. Genie. That is Genie. Yes. I'll give it to you. Waterfall. That's a
looks
new
like
one.
a
That's
waterfall.
a new one though. Maybe I should start calling it waterfall. What are you guys up to here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Not bad. Missing a couple, but
Is there a slide? It's right there. Slide left, slide right.
Oh
yeah. Anything else? You sure?
Oh, up, down. Like, like, like it
I'll
goes
give
up
it-
and it comes down.
Drop.
Yeah.
Or just here and it goes down. Yep. Anything else?
Black screen. Like it goes black.
I've never that. What do you mean? Me doing that? That's not a transition. I control that one, Fiona.
I don't
Okay.
know what it's called. Is there one that like explodes out, or is that like star?
Oh, that is.
Nope. That is called. Good job. Good job.
Shatter.
Okay, we ready to vote?
Oh.
Vote for whatever you want. Don't look around and think you got to be part of the crew. All right, no. You vote for whoever you think it is here. All right, how many cubes? Cubes. Going to be cubes. Stars. Book. 2 books. Curtains. Flip. Pinwheel. Genie. Promethean person again. Doubles. Nope. Clock. Slide left. To the right. Fade. Oh. Curl. Drop. Shatter. Okay. We got a tie, don't we? You know what? I'm so egotistical. I'm going to give you both because there's no shot you guys win this. All right, no shot. So you're actually going to pick. Oh yeah. There's some. It's very rare during it happens like once or twice a year, but I'll give you both. All right. I'm going to give you both. Sure. You don't have a shot anyway. I'll give you both. That may backfire on me, and I might flip out. But other ones that you missed. There's a spin one that you missed. Spin when it spins, and then there's also wipe, where it just everything just wipes away. It's
And
different
yours
than the
black?
slide. No, stop with the black. I just showed you. I do it. All right, are we ready for this? First one of the year. If it's star or fade, nothing. We ready? I'm giving you both here.
It's gonna be slide. It's gonna be slide.
We ready? Oh, page curl. Page curl. Curl. Oh, there it is. Nobody had it. Page curl. All right, up next. If you could, here with the time. Actually, we don't have time to get into groups, so if you can, go to the next problem and see what you can do on your own now. See what you can do on your own on the next problem. It involves parallel lines from last unit. I love introducing or reintroducing old material. The page curl guy. Remember, guys, anything goes. Anything goes. Sure, you can do exterior angle equals the two remotes added up. 180 degrees in a triangle. You can also do linear pairs. Alternate interior, corresponding. You can even find a blank angle that I'm not asking for if it helps you get to one of the ones I am asking for. Just so we're good. 44, 54, and $1.26 when you get there. Still got plenty of time here if you want to get to those answers. So as you guys can see, it's back out of the textbook tonight again, all right, for this weekend.
Wait, will you tell us the answer stop tomorrow or Monday?
For what?
That one.
Literally just came.
Oh, you're one.
You all right? You all right today? You're having yourself a day here.